Can you do it?
So, Ken, this is Gary. I might just say a few words before while people are thinking about what they want to say, but there's many, many interesting comments in the chat, and then you might look at that too, as well as those people speaking. So just two very quick things. I like very much the idea of looking at a neighborhood, as you mentioned, that Giancarlo had also mentioned. Um, but I would just point out that there has to be some structure to the neighborhood that should be understood. And of course, that's open work that needs to be done. And the only other point I wanted to make now, or idea I wanted to sort of surface now, is that this relationship or this idea of informal and more formal theories. I mean, I think there's a whole series of these things that are get connected over time. In science, for example, we have a Darwinian hypothesis that gets modified by a modern synthesis, and now we have modifications on that. And so over time, the theories predict more, take more into account, and get refined. Um, and that's just a very important way of understanding this. The same thing I think happens with ontologies as quote on theories about what is real. Uh, that it's useful to have a working hypothesis. It can be relatively informal, as you pointed out, but over time you try to find something that makes it either broader, deeper, or based on a better foundation. So with that, I'll stop and let the other people have their opportunity.
So yeah, I am looking at the comments. Let's see, Ravi, what did you say? Does this mean that learning more about something we have modified its theory?
Ken, it was in relation to,
The observer effect?
yes,
Right.
the observer effect.
The observer effect, right. In our case, for ontologies, there's no automatic, it doesn't automatically happen that creating an ontology is going to change your reality or change your ontological
But
commitments. I mean, I'm
is it
saying,
not very similar to what we do, say, in physics? We have a concept of a model, and as we try to find use cases, examples, experiments, we need to modify our models. Similar things must be happening to theories. And I see the diagrams from both our first two speakers, and I understand that they are trying to depict that same kind of thing in domain or theory model discrepancies or deviations, overlaps or non-overlaps. But are these very similar in say physics? You know both. You know
this
maths,
is
therefore you know both.
modifying the theory is not an observer effect.
Pardon me?
Modifying the theory or the model is not an observer effect. The observer effect is modifying the reality that you're modeling. It's the other side. In the case of physical reality, it's hard to imagine that our observing it has changed what reality is.
It does actually do that. At least at quantum level, we know the very fact of measuring something disturbs the equilibrium, and we cannot avoid it, but except for thought experiments, wherever we intervene to measure something, we perturb the system at least if we don't change the reality.
Yeah, no, I agree with that. What I'm saying
Yeah.
is that when we create a theory like the standard model, has that changed the universe? Because we
Uh,
have a standard model, is the universe different?
well,
I thought a
that,
better example of the observation is the
that's a good
entanglement
one,
idea.
Ken.
When things are
Eh,
entangled and you observe one, then it determines something else on the other side, which was indeterminate until then. But in terms of quote unquote a theory of changing reality, in the social realm, that happens when you redefine what marriage is or divorce. In the social reality, you can actually change that by changing your views on it. But I don't think that's what we're talking about in terms of the physical sciences.
Right? In social sciences and, in everyday life, I mean, it seems like observer effects occur all the time.
Yeah,
Um,
the very fact that the social media, the so-called social media, do change public opinion, and things go viral, and things of that sort. So people change opinion, or people act more passionately and contribute, like crowdfunding issues. So I do see that some in some social experiment sense, but my questions were more concentrating on three aspects, well, several aspects. I'm sorry to make it long, but one is obviously the connection between math and, say, physics. We stay limited to one branch of science, say physics. Second is uncertainty um, inherent in nature, and how it affects not only ontologies but also the physical theories. And these two for now. Third
well,
is
that's
on Hal Hilbert and Cantor, but we'll come to later.
that is an issue. I think. I think I mentioned it briefly. Um, why are we limited to first order logic? At least,
Yes.
yeah. Why not probabilistic logic? Um, why not modal logic? The other kinds of logic. Um, I would think that ontologies could be based on other logics. It would seem natural to do so. I'm sure that there are ontology out there that are at least that do have this property.
That does connect to things that Giancarlo either talked about, has written about in terms of these hard uh, patterns, foundational patterns, where we use a more informal design patterns, but he has rigid design patterns based on modal kind logic. So it involves necessity and possibility as ways of logically expressing certain things about the world. And those provide a more robust foundation for the simpler ontologies that you might use in different domains.
So why don't we let someone else chime in now? Um, who has been
Mike Bennett's hand is up.
Mike Bennett?
So,
You're here.
so we've moved on twice since I raised my hand, so bear with me. A quick comment first on your example of the ontology affecting the reality and so on. Sounds to me like the classical definition of a digital twin. So, a digital twin isn't simply something that mirrors a thing in the world. It's something that mirrors and updates and affects the thing in the world. So, I think that kind of view of ontology has a good bearing in the whole area of digital twins. And credit to Ken for not mentioning the OODA loop in that context, because that seems to be something that's very relevant there. So that was just a comment as we passed by that topic. But I actually raised my hand to follow up Gary's point about the neighborhood thing, about the something getting its meaning by its relation to things in its neighborhood and so on. And it reminds me, I want to run this past you all and see what people think, that it sounds exactly like what happens in cognitive science. So if you look at the semantic network in somebody's brain, the connective tissue is neurons rather than logic, but it's still connective tissue. And every point in the semantic network has its meaning by virtue of its relations to every other point that it's connected to, which seems recursive until you realize every point has its relationship to another point that has its meaning by relationships to other points that have their meaning by relations to other points, until you get to the qualia, the physical inputs of sight and sound and feeling and so on. And that's what we call the grounding of the network. So similarly with an ontology, every concept using the connected grounding of various levels of formal logic has its meaning by virtue of its relations to every other element, until you get to the bit where the meaning gets in, the grounding in reality, ideally in a number of simple primitive semantic concepts that can be linked back to qualia. So I just wondered what people thought about that.
Yeah, I think
So I have a
this
quick
could,
response, if I might, which is when you use a neural analogy of neighborhoods going on, you have to remember that there are activation levels that get involved and inhibitions that are possible, so that there isn't a fixed meaning based on the neighborhood.
Ah.
It's not a static neighborhood, it's a dynamic neighborhood. So the meaning that I get out of a statement varies over time depending on how my network has been going on and the latest thing that's happened in it. If I get the same type of proposition later on, maybe from a different person and so forth, it's a different, somewhat of a different meaning. So it's a very dynamic model of meaning with that neural approach.
Yes, but with one caveat there, the the thing that's hard to understand about the architecture of the brain, if we think of that in terms of like, you know, regular machines where some meaningful information is transmitted from one place to another, is that that never happens. In the neural network, the semantics is at the node. The activation is like the truth values. It's, is this node active or not? Is there, am I looking at a lion or not? But you're right, the changing of the weightings between things changes constantly. So every time we hear a word, we subtly update what we think that word means based on that new experience of hearing it. So the result of activation causes constant subtle changes to the meaning of a node. But the activation itself is completely orthogonal to that. It's the truth value. It's like the data.
Just another quick response before we get to Ravi. One can think of common sense meanings of things as trying to sort of average things across a population of people and what their mind is doing. So we sort of have some common basis. It'll vary, but the attempt to sort of say, well, this is the core meaning is some type of approximation about what you get when you take all those instances of people's activation.
That's right. And that's why when we do ontologies for industry, we try and lock down formal definitions that everybody can share, knowing that in the real world of how people perceive meaning, you know, every use of the word regime moves it from being a way of doing things to an evil bunch of people back to a way of doing things, depending on how it's being used. You know, the meanings change all the time. And so we use ontologies partly the same way that we originally introduced dictionaries, as a way of making that stuff stand still long enough to enable human and industrial communication.
anyone else have a comment?
Ken, I think Todd and I can see
Todd
Bobbin and I see Alican. Name I
and
can't.
Janet and
Yes,
Ellen.
and Alican.
Who would like to go next?
Let's see.
Janet.
Hi. Yeah, interesting. There's a couple of sort of simple and important topics that came up in what you're talking about there. One was that, I guess getting back to Barry's work, it seems that I don't understand how he's calling BFO a common sense ontology. And I came in late last time, so I didn't know if he had covered that, but then I watched the video and see that he hadn't. It was just sort of hand waving. I think that the work that they did actually challenges the whole notion, the whole realist notion of BFO, or as it being formal and therefore domain independent and realist. So I don't know if anybody is here capable of explaining what he means by saying it's common sense, but common sense is sort of the core problem in AI. And so his using that casually is problematic, I think. It also gets at the point that John always makes about the upper level of the ontology is to some extent separable from the core of a theory and its models, and which are what's actually used in a domain. And Barry's upper level is not really common sense in the way normal people would use common sense. It possibly is helpful to the domain experts in organizing their thinking about their mid-range theory that they want to use. But maybe it might be better if it was just nouns and verbs than continuance and occurrence and his special ideas about that. Anyway, so this is it's partly the question of what is an upper ontology, not necessarily what is an ontology, because I think everybody agrees that the mid-range theories, are the reference models in domains are very useful. But what is upper ontology is sort of the issue that this summit was prompted by initially, 20 years ago. And I think we still don't quite get that question. What is upper ontology? Is it needed? And if so, what should it be? Should it just be nouns and verbs, or should it be, each of these different special theories, especially in light of Jobst and Barry's challenges to their own framing from their examination of modern mathematics. Okay, I'm sorry, that's a big, long rant. I don't know if anybody else wants to jump in and talk about that topic.
Things I was thinking of talking about today, but no, wasn't that appropriate?
Todd and Bobbin.
What is mathematics?
Mm-hmm. Right.
And having been a mathematician, I can tell you that it isn't what most people think it is. The idea that mathematics is purely logical, that all theorems are, starting from axioms and going step by step through inference rules to get a theorem, just doesn't happen. That's not the case. And not only don't mathematicians do that, they actually claim that it's better that they don't.
Right.
They feel that they would limit themselves too much and limit the applicability of their ideas if they were forced to be totally logical. There's a nice book called The Mathematical Experience. I think you can actually get online. And by Davis and Hirsch. And I could give you a reference to it. And that'll tell you more about what mathematics as a community of individuals rather than, as some kind of abstraction really is. There's some interesting insights. And one of the things that they did was to give a little conversation, a little dialogue between an individual they call the ideal mathematician and a philosophy student. And it is hilarious. I really recommend that book.
Is that, what is mathematics really? Is that?
It's the mathematical experience.
Oh,
what is it like? What's the experience of being a mathematician and being in this community?
Okay.
But I don't think it's that relevant to us since, as Barry said, he presumed that we're in the Cantor paradise.
Or Cantor's hell, which I've also heard it described as. And that's interesting that Hilbert said that in response to Brouwer's challenge.
Yes.
And Brouwer is arguably more relevant to modern logic and AI, and questions moving beyond the pure world of Cantor's paradise. But I think the question about the mathematics there, it's any formalization. Any formalization is going to have an ambiguous relationship with our sensations. And Todd just suggested, maybe it's common sensations, but that's part of the problem of trying to pin down what common sense is. Actually, Michael, my research partner here, looked up the origin of the phrase common sense, and it was originally about fusion of sensations. It wasn't common knowledge. It was the way sensations are fused, which is problematic for AI and knowledge representation, because we're trying to separate. So when you're saying, Barry's not saying that BFO is the ontology of fused sensations. So what is he saying? And even following what Todd said, that it's common sense, common sensation. Then we're getting back to that interesting piece that was by John McCarthy, that was put on the forum again recently, I don't know, a couple of years ago, where McCarthy was saying common sense is the core problem. And I think Gary Marcus recently was saying that common sense is the core problem. So I think Barry was doing a bit of hand waving and saying that BFO is the ontology of common sense. I would ask you, and I'd like to, we'll be getting into this more through this summit, but I think the question is Michael Gruninger's piece also brought up this question of the relationship between mathematics and mathematics, formal theories, models, reality. Think that runs throughout all of the ontology development, no matter what topic you're dealing with. You're still moving between these different domains, in ways that I think were well brought out by Barry and Jobst. It's just that they didn't turn around and apply it to BFO. They kept it off in its own separate island, whereas I think it applies to everything that one is doing in ontologies.
Let's see. Yeah, thanks, Janet. But there are still other questions, and we're running out of time.
Ken, if I
Anything
might,
else?
I might have to leave soon, but for another meeting. But I just wanted to comment a little bit on the common sense aspects of what BFO. I take it, this is my own interpretation, to be what you base truth makers on. What are the relators, which is something that we can experience. And so we use those relators to ground something like BFO. And so it's more like a Newtonian mechanics view in part than a quantum view, which we don't have the relator experience directly for. So I think he would say much more about that, but that's my take on why he would say something like that.
Are you still here?
I'm sorry, Kenneth, did you call for me?
Yeah. Do you want to make some comments?
The only I'll leave it with this. If we do a word count, or maybe not exactly a word count, but something along those lines of all of these talks, one word that comes up over and over again is this term reality. And I've always had a problem with that. It appears, especially from what you said, Kenneth, in terms of the observer effect, this notion is problematic in itself. And we are basing a lot of our comments, our work, and especially Barry's notion of the notion of realism and Barry's use of reality in describing and using or applying BFO is a challenge, to say the least, from my perspective. I don't know if you have anything more you want to say about this notion. And that's why I put in the comment, Barry says BFO is common sense. It appears more that it's about common sensation. As human species, we seem to have some commonality in how we sense what we call temperature, what we call color, what we call force, and so on. I don't think my cat really cares about the qualities that much, but if she sees a little mouse close enough, she'll go out and try and kill it. She's pretty good at that, actually.
I think there's a whole branch of philosophy around phenomenology that addresses some of that question.
Yeah,
But from our perspective as ontology engineers, how should we construe this or deal with this notion?
I would propose that to a large extent, when we do, we create ontologies, we are usually not going directly back to physical reality. We're going back to reality in quotes, right? And I gave some examples like standards and laws, policies, things like that. What we are creating an ontology for is really just the next step in this incremental process of making, conceptualizing and formalizing, rather than going back. Maybe when we deal with, say, music, we can talk about music and how we enjoy music and what's going on when a musician is playing, without going back to the physical reality of audio phenomena at the
What do you mean
molecular
going back
level.
to?
We
All
don't
of that
go
is
back
taking
to
place.
that.
Well, what do you mean going back? As we're listening to music or as we're performing or playing music, we are making realizations of those things.
We are,
All of
but
that, all of those phenomenon.
when we make an ontology of, say, music theory, it's not based on particle physics. I don't think we need to do that.
Well,
We look
that would
at
depend on the requirements, right?
exactly, but for the most part, when people are classifying music genres, and things like that, they don't have to go back to particle physics. Probably wouldn't make sense for them to do so. As Barry was explaining, particle physics isn't even adequate for, talking about atoms with, half a dozen nucleons. Those are just far too complicated for us
Yes,
to be able to analyze.
it is.
So, we can do the hydrogen atom, we could do deuterium, perhaps helium. It's pretty hard to go anywhere beyond that.
I
It
have
seems
one.
unlikely that we could do the same for almost anything in our everyday common sense lives.
I think Todd is
Just had
actually maybe
one.
on the track of a resolution here. So I just wrote it in the chat: is reality to be identified with what we humans can sense directly, as opposed to supplementing our senses with material and mathematical machines. So the idea that reality is somehow what is naively perceived by our senses, I think, is problematic. And those two ideas of common sense, simple common sense or naive common sense and reality go together. Whereas what we actually do is we supplement ourselves with material and mathematical machines, but we ultimately get back to grounding and sensation. We ultimately get back to, if I operationalize my quantum mechanical experiment, you can end up sensing the same thing that I sensed. So the common sensation can be a quality control, but it doesn't mean that mathematical and material machines are not involved. which is where I think Jobst and Berry end up in quantum mechanics, is that it's machine dependent. We're extending ourselves with machines. That I think that's the way science and engineering works. So it's not that it's different in kind. I don't think it's ontologically different in kind from everything else.
So this theme has come many times. We know science to an extent, yet its engineering or product effects are very useful. I think Michael Gruninger also said that. And Mike Bennett today said something about cognition. And in that cognition in Eastern philosophies, not only mind and sense, brain and senses, as Mike described, are connected, but so are faculties beyond senses and brain called mind and intellect. These concepts come in cognition in Eastern philosophies. Just wanted to inject.
Well,
For
the
me
key thing
as
is,
a physicist, the guiding lights are mathematicians, metaphysicists, and philosophers. Just to praise Ken. Thank you.
well, the key thing if you're looking at these grounding or qualia or what are the sensory inputs is if you're creating an ontology for an organization, you're not necessarily looking at the sensory inputs of a human brain, but the sensory inputs of an organization. So sales and logistics and profit and loss,
Yes.
taxation, law, contracts, those are your qualia for a ontology for an organization.
Yes.
But don't those have to be grounded, operationalized in a way that comes back to the human beings, which is like a, it's a debug trace or a provenance.
Ultimately, yes. And so one of the challenges in building any ontology is you come up with a concept like, say, ownership, and you say, okay, so ownership is made up of the right to do this and the right to do that. Okay, so what's the right? This comes back to what I was saying about the semantic network. Every node has its meaning by its relation to the next nodes and so on. Okay, so what's the right? Oh, well, that fits between rights and obligations. And actually, a lot of these things in business come down to social constructs. And so John Searle does the grounding of that in that social constructs are grounded in human linguistic acts.
Right.
So you're right. You want to be able to chase down every meaning down to the sensory inputs, but you might not want to stand all that up in an industry ontology. You might just want to say, okay, social construct is my grounding primitive. Go look up Searle for the rest of it, and then that's one of your building blocks to build everything else out of. For example,
that's good. But with automation, we should be able to hide that. Ensure that it's in there for the quality control, and then hide it and reveal it as needed.
Yeah, well, the obvious way to do that, which not enough ontologists do, is a separation of concerns. The ontology that represents the things in the domain, your concept or explanatory ontology, is not the same as the ontology that wants to work on data. And when people try and combine the two, what happens is that the data ontologists start to shout at you about how the reason is getting slowed down by all these abstractions and can we kind of get rid of them? Well, you can if you have a separation of concerns. So your data ontology doesn't need to bother about any of that stuff. It just needs to reflect and be derived from it.
Right.
So I think we're coming to closure here. So we've run 15 minutes over. Anyway, excuse me.
Thank you, Kenneth.
Yeah, so I
Thanks,
think
Ken. Thanks, Ken.
I think
and
everyone,
hopefully-
I hope everyone is going to start looking at these challenges that I highlighted in my talk, and maybe we'll see some interesting new ontological techniques. I mean, would it ever be possible to have an ontology that has no entities at all? Just like there are topologies with no points? Is that
null or
conceivable?
empty.
Huh?
Null or empty. And I saw a lot.
Where everything is null. We have nothing but nulls.
Right.
That would be interesting, I think. if we could-
Nothing but arrows in your Yonido universe. You have to develop that for us. All arrows.
So think about that. There may be some interesting things we can do with this. It's been a powerful technique in mathematics. I mean, that was, of course, what I was working with when I was a grad student,
Mhm.
and later. So that's just one of the challenges that I listed, and I hope everyone will look at those and think about how we can enrich our field in the future by addressing these challenges. So-
Did John Soa just join us?
Yes, and we look forward
Yeah,
to
thanks.
hearing John next week.
So yes, I hope
Oh, yes, I'm
everyone will
here.
come to John's talk next week.
Okay, I'm sorry. I had a problem getting on, and finally, after all the attempts, just pressing Alt Control Delete solved everything. And but I missed the whole session. I'm very sorry about that.
But John,
Well, it was recorded.
next week you have to join us a little earlier.
Well,
because if-
I sent the title and abstract to the trustees, so you can post that for next week. That's the title and
Yes.
abstract.
I'll
Yes,
post it.
but I mean, you have to speak, so kindly be early next week in these various infrastructure testing, like sharing
Yeah,
slides
you're
and so
you're
on.
speaking next week. I hope you don't come in hour and 15 minutes late. But we're looking forward to hearing your talk.
Okay, well, I guess I'll look at the YouTube version of this, what I missed, but in any case, I'll make sure that if I have any problems, Alt Control Delete is the magic mantra.
Right.
And the slides have also been posted.
Thank you.
Yes, there was discussion here, John, relevant to your points, a number of your key points. So I think sets things up well for next week.
Okay, so with that, we will adjourn. Thanks to everyone for coming.
Thank you. Great session.
Thanks, Ken.